Today we are going to do inverse functions. Two functions, f and g, are considered inverses if you could take the composition both ways and get x as an answer both ways. So they are inverse functions. A function has an inverse if and only if it is 1 to 1, which we learned a couple days ago. Every first element, there is exactly one second element, and every second element, there is exactly one first element. The test that we use is to determine if a function has an inverse is the horizontal line test. Find the inverse if they exist. Okay, first thing we are going to do is to see if an inverse exists, and the way you do it is by graphing. So when I graph 2x plus 3 in my calculator, I'm going to just draw a little picture. I see that I get a line like this. Okay? So that line will pass the horizontal line test. So it does have an inverse. Now the way you find an inverse is pretty easy. What you do is you switch your x and your y. So instead of being y equals 2x plus 3, it's x equals 2y plus 3. And then you solve for y. So I subtract the 3. So I get 2y equals x minus 3. And I divide by 2 to solve for y. And you'll get y equals x minus 3 all over 2. Looking at the next one, y equals the absolute value of 4 minus x. Well, the absolute value of 4 minus x, I'm not quite sure exactly what it looks like. I do know it is a V shape though. So the absolute value of 4 minus x looks like something like that. If I draw a horizontal line, I hit at two different spots. Since I hit at two different spots, the inverse does not exist. So does not exist, D and E, because fails the horizontal line test, HLT. I'm going to have you guys try the third problem, and let's do the fourth problem together. The fourth problem, I'm going to save us just a little bit of time here, so I'm not using the whole time on the video. It will pass, if I graph it, it does pass the horizontal line test. So what I do is I switch my x and my y. So it'll be x equals y plus 3 over y. Now to solve this, what I do, I could try to cross multiply. So I'll get xy equals y plus 3. I'm going to get my y's together, so I'm going to subtract the y. Now, it might be difficult to see how I'm going to get that y by itself, but look what I can do. I can take out a GCF of y, and I'd be left with x minus 1 equals 3. And to solve for y, you divide by x minus 1. So you get y equals 3 over x minus 1. And that's the inverse. What this next part does is proving that the two functions are inverses of each other by using composition of functions. So it says use composition of functions to show that f of x and g of x are inverses of each other. If you go back to the definition at the top of this page, they will be inverses if f of g of x equals g of f of x, and they both have to equal x. So let's see if we can do this here. F of g of x first. You're going to replace the g of x inside parentheses with what it equals, 0.5x plus 1.5. Now what that says to do is plug that into your f function. So plugging it into my f function is going to be 2 times 0.5x plus 1.5 minus 3. 2 times 0.5 is x. 2 times 1.5 is 3 minus 3. X plus 3 minus 3 is x. So we're halfway there. We have to show the other way is also going to give us x. So g of f of x has to give us the same thing. First, going to replace the f of x with what it equals. It's a 2x minus 3. Now I'm going to, in my g function, replace the x with a 2x minus 3. So it's going to be 0.5 times 2x minus 3 plus 1.5. Distribute the 0.5 and you'll get x minus 1.5 plus 1.5. X minus 1.5 plus 1.5 is just equal to x. Since they both equal x, you have proven using compositions that they are inverses of each other. I want you guys to try the next one, which is asking the same exact thing. You guys determine if it is, you guys show that they are inverses of each other. Next one, it says, given the function, is the inverse also a function y or y not? Well, to determine that, let's just see if it is an inverse. And the way we do that is we try to find the inverse. To try to find the inverse, what you do is you flip your x and your y values. So 6, 8 becomes 8, 6. 2, negative 4 becomes negative 4, 2. 10, negative 2 becomes negative 2, 10. And 4, 4 flipped becomes 4, 4. It wants to know, is that inverse a function? It is a function if all of the x values only have one y value paired to it. And in this case, that is true. Since that is true, you will say that it is, so yes, and it wants to know why, because each x value has one unique y value. Well, let's look at some graphs. It says the inverse of the graph shown below will be a function. In order for an inverse to even exist, it would have to pass the horizontal line test. This is not passing the horizontal line test, so the answer is going to be no. Look at the next one. Since f of x is a reflection of g of x is also the inverse of f of x. The way you determine that is to pick a point, say on f of x. One of those points right there is 0, 4. The inverse function should have the point 4, 0 on it. So if I go out 4, 0, that's right there. Did your red graph have the land on the point 4, 0? It did not, so it is not true, it is false. I want you guys to try that third problem right there. Use the same idea that we did in the second problem. And also work on the other problems that we skipped for the do now at this point.